Okay, why don't we get started? If you can see me on the screen, I'm Dr. Justin Glisson. I'm the state climatologist for Iowa, and I work at the Iowa Department of Agriculture and Land Stewardship. And the Climatology Bureau, Bureau of One, which is funny to have a bureau name, but it is an excellent bureau, I should say. So what we're going to do today is we're going to talk about severe weather safety, and then we're going to talk about forms of severe weather, and then talk about what we've seen across the state of Iowa in terms of tornadoes over the last 30 to 40 years, to kind of give an idea of what we've seen and where we're moving. That's what climatology is, the study of weather and how we've progressed throughout the state. Let me mute some people. And just as a reminder, when you join, please mute your mic. Okay, so presentation highlights. What we're going to look at are severe weather types. Now, when we talk about severe weather types, we talk about thunderstorms and the things that they produced: high winds, hail, and tornadoes. And then we're going to talk about staying safe in severe weather. A lot of people are afraid of severe weather. That's actually why I wanted to start studying weather, because as a kid in St. Louis, where I grew up, I was deathly afraid of severe thunderstorms. I'm what you call a Weather Channel kid. I would sit in my basement and watch the Weather Channel because I was so afraid of severe weather happening. So finally, my dad took me aside and he said, "Listen, son, either you can be scared all of your life or you learn about weather." So I went to school for 12 years, have a master's and bachelor's in meteorology, which is the study of weather, and then a PhD in atmospheric sciences, which is weather and climatology. So that's how I'm here talking to you. I'm obsessed with the weather and climate, and that's what we'll talk about today. We'll also talk about thunderstorm and tornado basics, how a thunderstorm forms, different types of thunderstorms, and then how specific types of thunderstorms can produce tornadoes. And then we'll look at kind of how a tornado forms using some basic understanding of how air works in the atmosphere. Then we'll look at where it's most likely for tornadoes to form. We talk about the tornado alley. There's another section of the United States called Dixie Alley. These are two of the parts of the United States in which tornadoes are more likely to form. And I'll show you a graphic of that as we move forward. And then we'll look at Iowa tornado climatology. I'll discuss what climatology is, but basically it tells us when to expect tornadoes and what months are favored, what months aren't favored. And then the final thing we'll do is we'll look at notable tornadic events in Iowa, recent events like Parkersburg and the July 19th, 2018 outbreak. And then finally, hopefully we have enough time for some questions, but if we don't get to all your questions, I'll give you my contact information and I will get those answers to you. Okay, so the first thing, now that a lot of us are working from home, this is a bark warning. This is what we call the assistant state climatologist, George. He's my puppy. Now, sometimes he barks when I'm on conference calls, so this is your warning. As a coworker, he sleeps a lot, he takes a lot of breaks, and as I said, he barks a lot. So that's just something to keep in the back of your mind if you do hear barking. All right, let's get started. So this is from the Wizard of Oz, the tornado scene in the Wizard of Oz. As a kid, again, being scared of severe weather, this scene scared me more than the Wicked Witch of the West. And this was always seared in my mind as a kid. And again, that's why partially I wanted to study meteorology. So let's talk about thunderstorms. What we need for a thunderstorm are basically three things: warm, moist air, a lifting mechanism. We need something to push that air up, and then instability. You can think of instability in the atmosphere like those muggy days in June and July when you go outside and it's real sticky. That's kind of what we typically look at for instability. This tells us that there's enough water vapor in the atmosphere and there's enough energy in the atmosphere that we can force air to start moving up. And when you force air to start moving up, you start to get what's called an updraft. This is fast moving air that pushes the air up into the atmosphere. The air condenses, or it turns into clouds. And as these clouds form, you get heavier drops that we call rain. And we can also get hail in these storms. But basically you need a lifting mechanism to push the air up, and then you get a thunderstorm that forms. If you look at the video right here, this is actually a thunderstorm that's dying. This shaft of rain here is actually killing the storm because it's allowing, or it's blocking the fuel from getting into the updraft, which is right here. So this is what we typically think of as a small, what we call popcorn storm. They just pop up with the heat of the day and typically die after they rain out. Now, thunderstorms have a three-stage formation process. The first stage that we talk about is the developing stage, and this is when you get those puffy cumulus clouds that start to form. We don't get really any rain out of these because it hasn't had enough time to get the moisture condensing to form the cloud. This development stage is where the updraft starts to form, and sometimes you can get lightning. We call this heat lightning, and you can see it in the clouds. When we get into the mature stage, this is when the updraft has fully formed, and that updraft is that up arrow going up into the storm. Now you'll notice on a lot of thunderstorms that they produce an anvil, or that really flat top on the very high side of the storm. That's the air actually hitting what we call the tropopause, or the top of the atmosphere. It has nowhere to go, so it then fans out and you get an anvil forms. Now, when we're in the mature stage, this is when we have rain forming and falling out of the downdraft. We also get hail, possibly, if the storm is tall enough, because as you know, hail rotates up and down in the storm in the updraft, and that's how it's able to form more layers on it. So if you've ever seen a hailstone and you've cut it in half, you'll notice rings in it. And this is due to the fact that the storm has recycled that hailstone up and down, over and over again. So that's how hail can get big. Now, the typical mature stage for a basic thunderstorm is anywhere from 10 to 20 minutes. And as you see here graphically, the rain is falling out of the thunderstorm, and you get this cold pool that forms on the bottom. So the cool air that you get from rain actually chokes off all of the input, or the warm air, into the storm, and eventually the storm dies, and that's the third stage, dissipating stage. When we get into the dissipating stage, we have a decrease in the intensity of rain. We can still produce bursts of wind, and this is because the rain is still falling. It's cooling the air, and the cold air, of course, drops. If you've ever been in your basement in the summertime, it's always cooler down there because cold air sinks and warm air rises. So typically, if you're in an older house, your second floor is going to be warmer than your basement because of those basic dynamics. Now, we talked about types of severe weather. Well, we have criteria that we use to tell us how severe something is. A tornado, of course, any kind of tornado is severe weather. When we look at straight line winds, so winds coming out of a tornado, or winds coming out of a thunderstorm, anything above 58 miles per hour, a 5-second sustained gust or sustained winds is considered severe. So you would get a severe thunderstorm warning for 58 mile per hour winds or above. Or if you have hail that's above 1 inch diameter. Now this is an interesting picture right on the third here. This is a scientist at what's called the National Center for the National Center for Atmospheric Research in Boulder, Colorado. He's actually holding the United States record hailstone. This is an 8-inch hailstone that fell in South Dakota. Now, when the person who found this hailstone found it, it was actually 11 inches, so almost the size of a basketball. He actually had put it in a freezer to keep it because he knew it was going to be something huge. And his freezer actually went off because the power went out. So it actually melted a little. But again, 8 inches to 11 inches, that's a pretty huge hailstone. Iowa's record is a 5-inch hailstone. And then finally, flash flooding. When you get these high intensity rainfall events the sewer systems can't keep up with, you can get flooding on roads, flooding in streams. And this is when we tell people, if you see standing water on the street after a heavy rainfall, do not drive in that water, because it only takes a few inches of water to lift your car up. And that's something that we don't want you to do. So you need to be safe when you see standing water after a heavy rainfall event. If you go back to the first image here, this is actually the super outbreak back in the 70s, and anywhere from 150 to 200 tornadoes during this outbreak. So that was a very big outbreak. Luckily, we haven't had anything like that in Iowa. Now, I often get a lot of questions about what's the difference between a severe weather watch and a warning. Well, a watch means that conditions are present in the atmosphere to produce a severe thunderstorm. Or if conditions are favorable for tornadoes, you'll see a tornado watch. Now, when we get into warning territory, if you look at the graphic here, this yellow part of the map is where you have a tornado watch. So anywhere in that part of the country or in that part of your state or that part of where you live, conditions are favorable for tornadic development. Now, where you see that orange or red polygon there, that's an actual warning. And a warning means that conditions are producing severe weather or producing a tornado. So again, remember, straight line winds 58 miles or above, hail in excess of 1 inch, that's a little bigger than a quarter. Or if a tornado is spotted or indicated on radar, a warning will or a severe thunderstorm warning will automatically go to a tornado warning. Again, this is a kind of a summary slide for you to look at. Criteria, again, for the severe thunderstorm warnings, we've already gone over. And then the difference between a watch and a warning. Atmospheric conditions are favorable when a watch is issued. When a warning is issued, again, severe thunderstorms are occurring or are imminent. Same thing with a tornado. So the important thing to do, having been scared of severe weather as a kid, is always pay attention to TV, pay attention to the adults in your life. They'll keep you safe. They'll follow the severe thunderstorm safety rules. But I mean, if you find yourself alone and you don't know what to do, stay inside a sturdy, substantial building that you can protect yourself in. Your house, you would want to go to a brick and mortar store. You don't want to be in one of these big, like Lowe's or Home Depot, these big stores, because sometimes they can't protect you from tornadoes. If you're caught outside, find the closest shelter that you can. Knock on doors if you need to, because you need to keep yourself safe. Once in the shelter, stay away from windows, because damaging winds, hail, and tornadoes can blow out those windows, and you have sharp glass around. You'll also want to avoid electrical equipment, because sometimes lightning can strike your house or near your house, and that can go into your house, and that's a bad situation. Of course, it's always good to have a NOAA weather radio or a severe weather app on your phone from like WHO, because these will give you updates if a tornado watch or a tornado warning is issued, and that will give you a good amount of time to get ready for it. Again, one other thing that's the biggest killer in severe weather season is flooding and flash flooding. So you want to stay away from where water is pooling on the road. You never drive through standing water, because it can easily pick up your car. So those are things to keep in mind during severe weather season. Now let's look at some fun things. Tornado. So what do we call a tornado? What is the definition of a tornado? Well, a tornado is a violently rotating column of air extending from a thunderstorm to the ground. Whenever a funnel cloud touches the ground, that's what we call a tornado. Typically, if a funnel cloud is just that, a funnel cloud, it's not touching the ground, it's kind of skating over. If you look at this figure on the left, this is what we call a supercell thunderstorm. Now, I talked about the regular thunderstorm, the popcorn thunderstorm, when the updraft and downdraft kind of last for anywhere from 20 to 40 minutes. Well, a supercell is kind of a monster storm. And it's a monster storm because the updraft and downdraft kind of rotate around each other. So they're not able to interact. They can't cut off any kind of moist flow that goes into the supercell. So the supercell is able to perpetuate. It's able to last for a long time. We've had supercells that have lasted hours, stay on the ground. And these type of supercells are the storms that produce the long track tornadoes, the really big multi-vortice tornadoes that I'll show you moving forward. On the right-hand side here, this is what we call a squall line. Now, squall lines, more likely than not, you get straight line winds out of those squall lines. But if you look at where these little bends are in the squall line, where my arrow is here, that's where you can get a spin-up tornado because of the unique flow that's happening within that squall line. You can get brief spin-up tornadoes. Typically, they're not very strong, but they can be EF2, EF3 rated. So those are things, supercells and squall lines are the storms that produce our tornadoes across the Midwest. This is an example of a squall line coming into Des Moines. I actually took this on top of the parking garage outside the Wallace building where my office is located, and I'll play it for you. So what is happening here is you have a lot of cold, dense air that's coming out of the atmosphere ahead of a storm, and it produces these weird clouds called shelf clouds. Whenever you see an approaching storm like this, it's probably a good idea to get inside, because these typically will give you heavy rain, but also straight line winds that can be severe. So whenever you see this kind of configuration out in the atmosphere, get inside. Okay, so ingredients that we need for a tornado, basically 4 things: rising air in a thunderstorm, a change in wind speed near the surface. So because the surface is full of vegetation, buildings, all that kind of stuff, wind speed is not as high as it is as you go up because of friction. So if you rub your hands together, your hands get hot because of friction. Same thing for wind. The wind is moving through the trees, it's moving over the buildings, and it kind of slows it down. Now, as you move up in the atmosphere, there's less friction, so wind speeds become faster. So if you look at this figure right here, figure A, you have slower winds at the surface, but faster winds aloft. You get these horizontal rolls that form in the atmosphere. And these are typical in a very unstable atmosphere, which is another component of a tornado. You need moisture and instability to produce the rotation in the atmosphere. Now, you also need an increase of wind with height, and we call this wind shear, because when you have an increase of wind with height, you're able to start rotation. And that's what we see in where we have this big, tall thunderstorm. Because we have rotation in the atmosphere, you're able to produce what's called a mesocyclone. A mesocyclone is typically, the bottom of that is what we call the wall cloud, and that's where the tornado comes out. The interesting thing about the developing supercell is in the lower right-hand or lower left-hand corner here, that updraft is able to pick up that rotating column that's rotating horizontally in the atmosphere, and it pushes it up into the thunderstorm. And that's what sets off the motion. And once that motion is low enough in that supercell, that's when you get a tornadic formation. So I talked about Tornado Alley. In the United States is situated in a pretty unique part of the mid-latitudes where we live on the Earth. We have the Pacific and the Atlantic on the coasts, and then we have the Gulf of Mexico, which supplies warm and moist air into the middle of the country. Now, second part of this is we have cold and dry air from Canada and the higher latitudes that also tends to come down with the jet stream during severe weather season. And that jet stream is that fast moving air up very high up in the atmosphere that's able to increase the wind speed in these systems. And then finally, we get warm and dry air from the desert Southwest. All of those ingredients come together right in the middle of the United States, and that's what we call tornado alley. So when all those components come together, we know that a tornado outbreak is probably going to happen. Now, wherever you see this pink is what we call tornado alley, and that's climatologically, or that's where we expect tornadoes to form. We also have a Dixie Alley down here in the mid-Atlantic states, where we also have a high probability of having thunderstorms that produce tornadoes: Mississippi, Alabama, Georgia, Tennessee, and Arkansas. So these are the two parts of the United States in which we expect tornadic formation during the spring and summer. As you can see on Iowa, part of Iowa is covered in that tornado alley. So there is a higher chance of having tornadoes in the northwest half of the state, but we can get them across the state, and we've had them before. Now, you'll ask yourself, how do we know how strong a tornado is? Because we can't get really near it because of the damage that it does. Well, there's this scale called the Enhanced Fujita scale, and it's based on damage that a tornado does to structures on the ground. And it's a three-tiered system. So in the green here, we have weak, so EF0 to EF1. Those are minor to moderate tornadoes, don't do a lot of damage, can do damage to crop like corn and soybeans. You can see the striations in the field when these types of tornadoes form. And then we get into the second tier, the EF2 and EF3. And these are where we start to see damage occur, and pretty significant damage. Wind speeds on an EF2 up to 135 miles per hour, EF3 up to 165 miles per hour. So that's a pretty strong system that can do a lot of damage to not reinforced structures, trees, any kind of thing that's not bolted down. You'll get significant damage from EF3s. Then we get into the violent tornadoes, the EF4s and EF5s. These do not happen that often, but when they do, they produce a lot of damage. An EF4, wind speeds up to 200 miles per hour, and the damage is devastating. Then we get into the EF5s. These are the tornadoes that are the monster tornadoes. They're anywhere from 3/4 to a mile wide. Within the tornado, it's not just one tornado, but it's a system of tornadoes. We call them multiple vortices. And you can imagine tornadoes spinning around each other. That's what we get in EF5s. And when you see wind speeds 200 miles or above, that's when significant, incredible damage can occur. So these wind speeds, again, are based on the damage to structures. So if we're thinking of an EF5, we would see whole houses we would see whole houses removed from their foundation. We would see train cars pushed off the tracks. These train cars are tons and tons in weight, not easy to lift. Well, it turns out that EF5s can do that kind of damage. So if we want to look at this in the terms of damage, this was a tornado event in Texas. So we have the EF ratings of all the damage in this neighborhood, this one neighborhood, 2 or 3 blocks of damage. So if we look in the upper left here, we have EF0 damage. So not a lot of damage. Shingles come off the roof. You might have broken windows. And then you have EF1 damage across the top there. That EF1 damage, you're starting to get more significant roof damage, but not terrible damage. Where we start to see catastrophic damage to terrible, devastating damage is down in the EF2, EF3, and then EF4 to EF5. Now, I mentioned that EF5 damage is particularly devastating because those tornadoes are able to completely pull off the house from the foundation. So you effectively only have a slab left on the structure. But what I want to show you in this picture, which is very interesting, is you're going from 2 blocks, from EF5 damage to EF0 damage. So very variable wind speeds within these large tornadoes. So you can have damage that is catastrophic in one part of your subdivision, and then you go to 2 or 3 blocks north and everything's fine. That's how strong these storms are. So that's why we have to be proactive when we do issue tornado watches and tornado warnings. Okay, so now we'll look at Iowa tornado climatology, and I'll discuss what climatology actually means. And then we'll look at tornadoes by year since 1980, and then average tornadoes per month to give us an idea when we can expect tornadoes across the state of Iowa. And then tornadoes per EF range. How many EF5s have we had across the state? How many EF0s have we had? And this gives us an idea of the strength of tornadoes across the state. So first I want to just basically talk about weather versus climatology because I get a lot of questions about this. Weather is the day-to-day state of the atmosphere. So we've been talking about thunderstorms and tornadoes and severe weather. That's weather. You would think on the scale of seconds, so a tornado or a thunderstorm, all the way up to about 7 to 10 days when you get those low pressure systems that move across the United States that brings us our rainfall, our snowfall in the winter, things of that nature. So when we're thinking about weather, it's a combination of temperature, humidity, what type of precipitation we're getting, cloudiness, what's the wind speed. So you can think of weather as how hot is it right now? Or are we going to have rain this week or next week? When I give presentations to elementary school kids, I tell them that you can think of weather as the clothes you're currently wearing. Now, when we talk about climate or climatology is the actual average of weather for a given spot over a period of time. And climatologists like myself use a span called 30 years, which is a climate decade. And that gives us a good average or a good baseline that we can start to compare weather for a given location. Tell us, is this weather that we're experiencing above average or below average? Is it within the range of, we can expect temperatures are 5 to 10 degrees above average, but if we look at the climatological rank for a month, it's not as warm as we thought it was, given across the state of Iowa, we have 148 years of records. So we have a very long and robust temperature and precipitation record across the state. That allows us to tell our stakeholders, well, the weather that we're seeing now is not as extreme as you would think. And that's part of my job as the state climatologist. So long story short, climatology is what we expect and weather is what we get. So when I tell elementary school kids that weather is the clothes they're wearing today, climatology are the clothes in your closet for the next season, because we always expect that summer and winter are going to be cold and warm. Graphically, what we can look at is the day-to-day variation in temperature or precipitation. That's weather. We call those the weather wiggles. Now, when we average all those wiggles together, we get the green line, and that green line is climatology. That's what I study. Another way of looking at it, again, winter, we always think it as the coldest season, summer is the warmest season. Lots of variability. We can have above average temperatures in winter and below average temperatures in summer. But when we average out winter and summer and get the annual average temperature, we're pretty much within a 1 degree or 2 degree spread with what we expect climatologically. Okay, now let's look at tornadoes in Iowa. This is a plot going back to 1980 of the amount of tornadoes in a given year. The axis on the left here, the vertical axis, is the number of tornadoes. And the total that we've seen since 1980 is 1,928 tornadoes. Now, if you look at the spread for each year from 1980 to 2018, we had a pretty active stretch between 2001 to 2008. So if you look at the tornado record, you see lots of bumps and valleys there. So it's always hard to forecast tornadic activity moving into spring and summer. We kind of fall back on climatology or what we expect. But again, if you look at 1996, we had 22 tornadoes. And in 2005, we had 120 tornadoes. So lots of variability. So it's always difficult to get an understanding on when tornadoes will occur. Now, if we break that down monthly, climatologically, June is the month in which we receive the most tornadoes. So going back to 1980, the month of June has by far the most tornadoes, 561, followed by May. So that May-June time frame is when we expect the most tornadoes across the state. If you look at the bottom right here, these are tornadoes by the EF scale. So again, these not so violent EF0, EF1 tornadoes, those are the tornadoes that we typically get across the state. Since 1980, we've had 16 EF4s and only one EF5, and that was the Parkersburg tornado in 2008. Now, if you look at the bottom left here, these are the rank of tornado outbreaks that we've had across the state. If we look at April 31st, 2014, we had 35 tornadoes, so that was a big outbreak. I'm running short on time, so I'm going to kind of go through these slides pretty fast so we have some time for questions. The Parkersburg EF5 occurred on the 25th of May in 2008, and it was a powerful and discrete supercell, so it was a thunderstorm that formed by its own in its own environment, so it was able to gobble up all the fuel that it needed to form, and this formed west of Waterloo. The peak sustained wind gusts were estimated at 205 miles per hour, stayed on the ground for 43 miles, so that's a pretty significant track, 12 miles of which was EF4 to EF5 damage. We had 17 houses and industrial buildings sustaining EF5 damage. Unfortunately, 70 injuries and 9 fatalities. And this was the first EF5 or F5 to hit Iowa since 1976. A very interesting fact here is lightweight material from Waterloo, like cards and check stubs, were found 100 miles away to the east in Prairie du Chien, Wisconsin. So here we'll just look basically, here's the track of the Parkersburg tornado. Where you see pink is EF4 or EF5 damage. So a pretty good spread across Parkersburg to New Hartford. Bottom right here is the actual tornado on the ground. Again, multiple vortices in there, multiple tornadoes within that big wedge. And you can see some of the damage. Grain bins were destroyed. And you also get these striations on the ground that show you how these little vortices interact with each other. So you get swirl marks across the cornfields. Here's a video of from an ATM at a bank on the day of the Parkersburg F5. Now I'll draw your attention to this tree over here, and shortly you'll see some flashes. What these flashes are, it's not lightning. This is the tornado actually hitting power lines, and you saw the pop right there. You can start to see inflow into the storm, so from right to left. And then finally, the wedge starts to move in. You start to get damage to the roof. And then finally, the whole thing goes. So this gives you an idea of the veracity of these EF5s. And again, only one since 1980, but it did substantial damage. Okay, more recently, the 2018 July 19th event, we had three EF2 or plus rated storms. 2 EF3s hit Marshalltown and Pella, and then we had 2 EF2s that formed over Bondurant. Let me go through these fast. This is the Marshalltown track. Path length was almost 9 miles, EF3 rated, did a lot of damage. Pella, again, EF3, hit Vermeer, and this was actually the Pella supercell from the parking garage at the Capitol complex. So Pella is 40 to 45 miles away. The tops of these thunderstorms were anywhere from 50 to 55,000 feet. So very, very substantial thunderstorm. This was the damage that was caused at Vermeer. So very substantial damage. And this is why you don't want to be in a store that has a big roof on it, because this will happen. Finally, the Bondurant tornadoes. 2 of them actually formed. We call them sisters, 2 EF2s. The path lengths on those were 2 to 4 miles. Not very big, not very fast moving, but did a lot of damage in a subdivision right out in Bondurant. What you're looking at here are one of the tornadoes forming, and it's hitting a substation, and you get those power flashes. So you can see the intensity at which the storm is pulling in the air. Here is my contact information, because we're limited to 40 minutes on Zoom. So please take this down. This will also be shown on the Iowa Department of Agriculture's social media platforms. So you can ask questions there as well. Let me see if we have any questions in chat. If you do have any questions, please let me know. Or, yeah. Should I unmute you all? That might be.
Has been looking for lunch.
Hello.
Hello.
Let me mute you all. Hold on. Okay, we got a question here. If you're in a car and facing a tornado, do you stay buckled up or hunker down? Yes. That is a very good question. So if you're in a car, the best place to be is driving away from that tornado, of course, buckled in. Now, the last resort, if a tornado is coming at you and your last resort is getting into the lowest part of where you are, you need to get into a ditch. But your best bet, if you're in a car, is to stay in that car, drive at 90-degree angles away from the tornado or the storm. And yes, that's the best way, is to stay in your car. I got a question from Sarah. Henry wants to know, have any tornadoes hit Des Moines? Yes, they have. We've had many tornadoes hit Des Moines over the years. Nothing very substantial, but we have had some damage that has occurred. Another good question, if you do happen to be in a big box store when a tornado hits, where is the safest place to be? Very good question. If the store has a cooler, like if you're in a grocery store and the grocery store has a cooler in the back, get into that back space. Now, these typically businesses will have a tornado plan that if a tornado warning is issued and you are in the store, they will give you the best advice on where to go within the store. Any other questions? Does an EF5 tornado last longer than any other tornadoes? Yes. And again, an EF5 is a 99th percentile, an extreme storm. The reason why it's able to perpetuate itself is, again, that supercell. You have the updraft and the downdraft in the thunderstorm. Those supercells, the updrafts and downdrafts, are wrapped around each other. So they're not able to choke off any fuel coming in. So the longer that supercell is on the ground, if it's in a clear environment, if it forms by itself and it's able to take in all the fuel, it can be on the ground for 40 to 60 miles. So yes, an EF tornado, EF5 rated tornado will be on the ground the longest and produce the most damage. If you're caught outside in a tornado, what kind of shelter should you look for? You look for any shelter you can find. The most sturdy shelter you can find is your best bet. You do not want to be outside in a tornado. Where would you go in a campsite if there's a tornado? Typically, like state campsites have warnings that they will issue if there is a tornado coming at you. If you have enough lead time, if we know that the tornado is 15 to 20 minutes away, you can leave that campground as using that driving instructions that I gave you earlier. If there are sturdy structures on that campground in which you can take refuge in, those are the type of structures that you would get to. Yeah, but it's campsites vary from small campsites to the big ones run by the state. So it just varies on where you are. But again, you would want to find the sturdiest structure you can find. No, okay, this is a great question. They used to tell you to hide under an overpass if you were traveling. Absolutely not. This is the worst place to be. When you're under an overpass, that acts to squash the wind. It compresses that wind field. So you're actually getting higher winds moving under an overpass that can suck you out. Also, people like to park their cars under overpasses when it's hailing or when you get a very intense rainfall. people won't be able to see the lights under that overpass, so you're more inclined to be hit by cars on that highway. So an overpass or a parking garage are the absolute worst places to be in a tornado. Very good question. Okay, well, if there are no more questions, again, please take down my contact information. Given the current situation, I can't get out and do presentations. So yes, please give me a call, please email me. Always willing to talk, answer questions, and thank you all for being here. I appreciate it.